Hi everybody, I'm Yair from the Dog, and welcome to our Python for Beginners tutorial. This Python course was designed for a complete beginner, so if you don't have any prior knowledge, don't feel bad about it, you came to the right place. Also, if you have some background in Python or any other programming language, you also came to the right place because I do believe that you could benefit from this course as well. Why Python? First of all, Python is very easy and intuitive. You will have fun to learn it. Secondly, its popularity grows every day. In the latest report that you can find online, Python was ranked second most popular programming language. Studying Python can benefit you and help you to acquire your dream job. The third benefit in studying Python that you can find so many tools online that you can integrate with Python. For example, we deal with Selenium and testing automation, so we can use PyTest and also Selenium for Python. Another aspect of Python that you should be aware of is that Python can be used as an object-oriented language or as a scripting language. If you'll stick until the end of this course, you will study how to install Python in your computer, how to use Python IDE, how to execute your Python code, how to store values in variables, how to build your Python functions, how to create lists as more complex data structure, how to use logical statements, and also how to perform arithmetic calculation using Python. I hope that you will enjoy this course as much as I enjoyed making it for you. Also, if you like this video, give us the thumbs up, and if you haven't subscribed to our channel, please do it now. Let's get started. Hi everybody, I'm Yair from the Dog, and I'm excited that you join us with our Python for Beginners course. In this course, you'll study how to install Python and Python IDE. We'll also go over the basics such as writing our first program, variables, and other stuff. We'll study about conditions, comparison between variables, logical statements, and loops. In later chapter, we'll study about functions, the structure, the conventions in Python, about local and global variables. We'll also deal with how to maintain your code, how to write comments, how to use the debugger, how to add hints, and advanced prints. In the end, we'll set the foundation for a more advanced knowledge, and possibly for another course in the future, we'll study how to use nested loops, conditions, other data structures which are more complex than regular variables. We'll study the foundations of object-oriented programming in Python. Let's get started by installing the Python and the IDE. First, we'll need to install Python in our system. Python supports Linux, Windows, and Mac. We'll study how to do that. And also, we'll use PyCharm IDE. The IDE is the integrated development environment. It means that we have a coding environment that will help us to better run our code, to maintain it more easily, to install necessary plugins. By the way, Python can be fully executable from command line tools and from other editors such as Notepad++ and Sublime. I prefer PyCharm because it's really easy to use and it overall a better coding experience. Let's start by downloading Python. We'll head over to this URL, python.org. You can see here that we can go to the download section and we can download Python. In my case, it's Mac OS. You can also refer to download for Windows or other platforms. By the way, we're using Python 3, and you should download the latest version to your operating system. Now we'll head over to jetbrains.com/pycharm. We'll click download and we'll select our operating system accordingly. Let's do it together. Here you can see that you can choose your operating system, whether it's Windows, Linux, or Mac. You have the Professional and the Community Edition. The Professional Edition is a paid version of PyCharm, and it also offers a free trial. For our purposes, the Community Edition is great and is sufficient. So you should download this one. It's free and it's open source. Now we'll open PyCharm and we'll start a new project. We'll also create a new project and give it a name. It could be any name that we want. And also we'll go over the interpreter. The interpreter mainly deals in converting our code to a bytecode and then to a machine code that our computer can execute. So let's start PyCharm. We'll create a new project. We'll give it a name. Because I already have a project with the same name, I'll give it Python for Beginners 2. By the way, in Python, the main convention in files and methods, whenever you have different words, consecutive words, you should use an underline. It's not mandatory, but it's the way that most people are writing the language. So your code and your general structure will be more understandable. Here you can see that we have the project interpreter. You should make sure that the location of the interpreter is the location that you've installed your Python. In this example, my interpreter is located under user, local, bin, Python. Also, you can choose an interpreter, whether it's built in the PyCharm environment or from another place. As you can see here, I have the 3.7 because I've pre-downloaded it. But if you'll download now, as you saw in the website of Python, now the most stable version is 3.8.5. We'll click Create. Those are some useful tips that we get. You can close it. You can choose not to show it on startup by unchecking this button. And this is our root folder of the project. In this section, we'll go over the basics. We'll write our first program. Our first program, of course, will be printing the hello world. Print in Python, by using brackets, will print any string or variable to the console. It's very useful, especially when you want to deliver some messages to the console during execution of a certain program. We create a new Python file. I'll show you in a second how to do it. Then we will use the print to add values. By the way, as you can see here, inside the brackets you have the quotation marks. It means that this value is a string. It's a regular text. We'll see soon enough how to use variables as well. And we'll run the program and watch the console. So let's start by clicking the root folder, a right click. New, we'll choose new, this is the first option, and then we'll go to Python file. Click on it. Let's give it a name. We call it first underline demo. Here we write down our first command, print hello world. In order to execute it, we'll just right click anywhere in the area of this file and we'll choose run first demo. That's the name of our file. This is our console output. You can see here that it's written hello world. Variables. In Python, you don't need to specify the variable type. In other languages such as Java, in order to have a variable of type string, for example, or an integer, you need to specify this type before. There are some other languages such as JavaScript that you need to write down that this is a variable with adding the var prefix before the name of the variable, but in Python you don't need that. By using the equality mark, we assign the value to the variable. There are several variable types such as string, integers, floating point, and boolean. We'll overview all of them right now. So as I just mentioned, let's say my variable name is a, and I use the assign mark, and I want to give it the value 3. Now I can print the value that is now stored in a by using the same function as I use for the hello world. I'll right click on it and run the first demo. Now I have 2 lines in my output. The first one is the previous line that we executed, the hello world. Now we've printed the value that was assigned to a and is stored in this variable, and it's 3. We can assign some other values such as a floating point value. In this example, I've declared a variable which is its name is b, and I've assigned the value 2.3 to it. It means that it's not an integer, it's not a complete number, it has some decimal point after. And if I print b, I'll have another line in my output. We can also make something more interesting. Let's say we want to print the message. We'll assign the hello world variable to a string variable, and the name of this string will be message. Now I can print the message here. It will be the same. The console output will be the same. The implementation in our code is a bit different. And also I can override this value. Let's say here in line number 9, I'm using the same variable message. As you can see, it was predefined, and now I'm changing its value to hider. Now I can reprint message, and let's watch the results. I right click on it and run the first demo. Now here we have the hello world that was printed here in line number 2. Then we have the previous variable that were untouched. And now the value under message was changed to hider. It means that the value from the beginning, from line 1, was no longer there. It was overridden by line number 9. We also have a Boolean value. A Boolean value is very important in any programming language. It means a value of true or false. Let's assign it to a variable with the name C. If I'll print C now, I will get true. You can see it here. Of course, if I'll change the value to false, it will also change the output. If I rerun it, of course, yeah. You probably have noticed that I get some warnings sometimes. In this example, I have no new line in the end of the file. Because Python is very strict on structure, it gives us some warning. This warning won't affect our code. It won't interfere with its functionality. But in order to have our code run perfectly without any warning, and also that the structure of the code will be according to the conventions of Python, we'll press enter, and now we don't have the warning anymore. There are some other warnings. There also can be warning about typos. For example, if I'll make a mistake, a typo in this word, you can see that there is a typo in the word there is. The dictionary does not recognize this word. Every programming language requires a logical statement in order to make it much more interesting that the program will do something. Until now, we just saw that we assigned a value to variables, but we didn't do anything with this assignment aside from printing it. We can also add several consecutive conditions. We'll have a look at this now. A condition in Python can be written like this. If, for example, we have a, if a is equals to 3, print yeah. Let's have a look on the structure of the if, and then I'll also talk about this logical operand. So the structure of the if statement is first if, by the way, you saw that if and also false here are reserved words. We can use those as, for example, as a name for a variable because it's words that were reserved by Python. So we're asking if a equals to 3, and also we have the colon here. After that, whenever we want to include some code under the range of this specific if, we need to make this indentation. By the way, PyCharm is doing that automatically. You saw that I pressed enter here and it was already here. If it won't happen, you can also use tab. You'll use one-time tab and you can see that now it's nested under if. The difference between a equals 3 then c equals something is here that this equality mark is an assignment. We take this value and assign it to the variable, and here we're asking if this particular number or any variable is equal to the value that is stored here. If it will be equal, it will be written yeah. Let's run it and see what happens. Yeah. You saw here that the yeah was printed. Let's make it more interesting. Now we can say else, include the colon, we'll print no. Let's change the value of a to 2. Now we expect that line 18 will be executed because this logical statement is not valid anymore. You can see here that now the no was printed. We can also ask several consecutive conditions. For example, we can use elif. Elif means that if this wasn't true, we can retry. Maybe we can ask, is a bigger than 0? We can print a is a positive number. Now the else would refer to those two. First we'll execute line number 15. Then our code will ask, does a equals to 3? We know that a equals to 2 now. So this won't be a valid statement. Then it would ask, is a bigger than 0? In this case, yes, a equals to 2. So we'll print this line. In any other case, if a is not bigger than 0 or it's not equal to 3, we'll print no. Let's see that happens now. Let's run it. See, a is a positive number. If we'll just change now a to -2, we'll probably get this line now, line number 20. So the first condition wasn't met, and then we asked maybe this number is bigger than 0, and in the end we printed no. We can add as many as else ifs as we want. Let's say we want to ask also if b is bigger than a. B is bigger. Let's rerun it. Because b equals to 2.3 and a is -2, we could say that b is bigger. I bet you get the idea. Also, we can have some different type of conditions. Maybe we can ask if b is bigger than 0. So we'll write down b is positive. We'll also ask if b is bigger than 3. B is the greatest. And we can also ask if b is bigger than a. Let's say we want to encourage b and tell it, yeah, b. Okay, so now what happened here? The difference between the conditions that we met in the previous section is that this condition is a standalone condition. It means that it will first ask if b is bigger than 0. It doesn't matter what would the answer would be. If b is bigger than 0 or no, it will just print or not print this line. But it will also ask after if b is bigger than 3, and after it will ask if b is bigger than a. So all three conditions would be considered. In the previous case, if one of the conditions during the way were met, so the other were ignored. If we'll add here the else, so it means that this else would refer only to this. Okay? Let's run it and try to understand what happened. See, b is positive. That's the only line that was printed. But if we'll change b to be bigger than 3, we'll get this line and this line as well. Yeah. You see that here we had a warning. It doesn't have any effect because I forgot to add the print here. So now let's rerun our code. We have now 3 times that it was printed. Here the first one was b is positive. The b is bigger, by the way, is coming from here, from line number 20. But on these conditions we had print b is positive, b is the greatest because it's bigger than 3, and also b is bigger than a. So we also printed yeah b. In case this condition wasn't met, so we would print the IMD else. We already studied about the comparison with the equal operator, but there are some other operators that we just saw. We can use the bigger than, smaller than, unequal or not equal, and bigger and equal. Let's see an example. If b is not equal to 3.3, print that's not the exact number. Now the else would refer to line number 30 because I've just added this line. We can add any else to another condition if we want, but in this case this else only refers to this condition. So it means that now if b is not equal to 3.3, we'll get this message. We can also ask if b is bigger or equal to 3.3, and now this message would be printed. That's not, oh, maybe the message is not so understandable, but because b is equal to 3.3, we ask is b bigger or equal to 3.3, and then we printed it. We can add some more complexity to our conditions by using the words and or, and we can also negate a certain condition. Let's have a look. Let's say if b is bigger than 3 and c is false, because c is a Boolean value, we ask c is false. You see that all of these orange words are reserved words of the language. Let's write down our complex condition was met. Let's run it now. You see here that the console printed that our complex condition was met. By the way, if we'll change the value in C to be true or not false, you see that this print didn't occur because either B wasn't bigger than 3 or C wasn't false. We can also change it to is not false. Okay, it means that if C is true, not false, it will print this condition. Let's run it. Now you can see that our complex condition was met again. Using an OR could lead to a softer condition. It means that either B would be bigger than 3 or C would be not false. It will print it. So let's have a look. Now we expect that this line would be printed, as you can see here. And if I rechange the value of C to be false, now because I'm using OR and not AND, it means that either B is bigger than 3 or C is false, is not false. One of them is sufficient already to fulfill our condition. The next section will be about loops. Loops can help us to run our code multiple times until a certain condition is met. The basic loop is a while loop that will run while this condition is currently met. We also study about other loops as well. Let's try to see while while A is smaller than 10. What is the value of A? A is minus 2. So A is minus 2 is smaller than A. If I print here A, that's the value, what do you think would happen? By the way, as you can see, the syntax of this while loop is very similar to the if. We have the reserved word while, we have the variable and the logical statement, and then we have the colons. Also, we have the indentation here. Let's run it. What do you think would happen? Okay, there is no stopping condition of this loop. Nothing happened with A. For, let's say, for an infinite period of time, A would have the value minus 2. So it probably would run and print minus 2 for good, or until the memory in my computer would be filled with this -2. So what do we need to do? After we print a, we need to add some number to advance a until it will be equal to 10. So we can say a is equal to a plus 1. We can also say a is equal to a plus 2 or plus 3, but we want to see that a is starting at -2 and in the end it will be equal to 10 or less. So let's run it again. Okay, now we have a started in -2, then it became -1 because we added 1, then the value was 0, and then it advanced until 9. Why until 9? Because we said whenever a is smaller than 10, just continue. In this case, a was already 9, and then when we added after we printed 9, we added another 1 to a, the value in a became 10. And then it means that a was already equal to 10, not smaller than 10 anymore. So the 10 wasn't printed. Of course, we can also say smaller or equals. Now we'll have also the 10 printed here. See? From -2 until 10. A for loop is a very useful loop that can run in an index in a certain range. There are also for each loops that we'll study later on in this course when we'll study about more complex data sets. The syntax of a for loop is also fairly easy. For index, that's our index, in range, let's say in the range of a, let's print our index. I want to show you something. What is the range of a? First, we assign the value to a. The first time was -2. Then we used the variable a and we reassigned values to a. After the while loop that is in line number 38, change the value of a to 11. Why? Because when a was equals to 10, it still printed 10 and then added another 1 to a. Now the value of a is 11. So it means that the range of a is 11. By the way, I could write down the range here like just a number, but I wanted to make it more dynamic. So let's run the for loop and let's see what's the index that would be printed. Okay. So here we have a lot of numbers. Let's print a divider between our console prints. Let's say we want to print some stars. Okay. So we would know that this loop has ended and this loop now starts to print. Okay. Here is our divider. So what was printed until this line belongs to the while loop, and now we start with the for loop. Why the index started 0? Because 0 is our first number usually in arrays in most programming languages. It means that we start in the 0 index and then we advance. The first one was 0 and then 1 and then 2. So it was in the range of a until it reached the 10th value, which means it was the 11th value because we started at 0. That's why we've printed this index so far. Functions in Python. In this section, we'll study about static functions, indentation, and how to call a function. What is a function? A function in Python is a block of code that is being executed upon call. A function can receive parameters. It can also return a value. There are static and dynamic functions, which are called methods. We'll deal with those type of functions later on in this course. In order to define a function, we start with def. Followed by def, we give a second value. It will be the function's name. It should be also followed by parentheses and a colon. Let's have a look at the code example. Let's create a new file. We'll call it functions demo. Here I will define a function. Let's call it my function. As you can see here, the def part, just declaring of the function. Here is the name of the function, the parenthesis that can receive parameters. We'll show it in a bit, and followed by a colon. That way we can define our function. It doesn't have any content now, so I can just write down pass, and this function won't do anything. I want to tell you something about the indentation. Indentation. To include a certain code under the functions block, we use indentation. Any code that is indented under the function is a part of the specific function. What do I mean by that? Here you can see that my function is aligned to the left, the most left hand side that can be possible, and under it it's indented with tab. By the way, PyCharm is doing that automatically. Here everything I will write down would be part of the function. Let's write down I'm inside the function. Of course, that if I'll try to execute this file, nothing would happen. Why is that? You probably guessed right. Nobody is calling our function. How to call a function? In order to call a function, we just state its name with parentheses. If we have a parameterized function, we can pass parameters to it upon call. We'll deal with parameterized function in the next slide. If we write a function in the same file that we are working on right now, and we don't call it from an external file, it is important to call the function after its definition, because Python usually read the code by its order. A function can also call another function. Let's look at an example for all of these. Okay, so now we need to call our function. I will do it right here. And now, when I will execute this code, I have this print to the console, I'm inside the function. Of course, if I'll take this call to the function and try to call a function before I define it, it won't work, because I will get this error, unresolved references my function. My code doesn't know that. Okay, so I call my function here. Let's define another function, my second function. And let's print I'm inside the second function. As I wrote down in the slide, I told you that we can call the second function from within another function. Let's call my second function. By the way, you saw that PyCharm gave me the opportunity to call my function. A function can call itself, but if it will call itself and we won't stop it anymore, what would happen, do you think? Let's try and find out before we do the other thing. So here we call in line number 5 to my function, and then after line 2 is being executed, my function will call my function, it will call my function, it will call my function. Okay, let's run it. Okay, you see, so we have very large amount of prints here, and in the end I got an error which said maximum recursion depth exceeded when calling a Python object. Okay, so I tried to call this function and it was repeated almost 1,000 times. Of course, it's a bad practice. You can use recursion, but we won't speak about it in this course. Okay, so now my function will call the second function. So let's try and figure out what would happen. Okay, so between line 1 to 3, I defined a function which its name was my function. Then between line 7 to 8, I defined a second function. Line 5, by the way, it doesn't matter if line 5 is here, or I can just move it down. It will make more sense. By the way, you saw the indentation here. If I would paste it here, so nothing would happen because nobody is calling either my function or my second function. Of course, I can just move it to the left hand side, and then after the definition of these functions, line number 9 will call my function, will print I'm inside the function, and then it will call my second function and the second print would occur. Let's try and run it. As you can see here, I'm inside the function and I'm inside the second function. Let's try and alter it a bit. If we'll take line number 3 and we'll change the order, what do you think would happen here? My second function would be called first, so this print would occur, and then this print. So probably those two would change the order. Okay, let's try and run it now. Okay, here it was printed I'm inside the second function, and then I'm inside the function, which is the string that we are trying to print here. Functions can be parameterized. We can pass any parameter to a function and we can add it inside the parentheses. We can also pass several parameters separated by a comma. Let's define another function. We'll call it def my parameterized function. Okay. Here we can pass a parameter. Let's call it x and y. Let's print x, sorry, it's a lowercase x, and let's print y. Now I need to call this function. Instead of just calling it like this, I will call my parameterized function and I will give it some values, 3 and 5. Let's run it now. Okay, you see, first my function was called on line number 13, then my parameterized function was called on line number 14. Then inside this function, the print of an x and then the y. Of course, if I'll change the value of x, now we'll have 8 and then 5. Local and global variables. When we declare a variable inside a function block, this variable is unknown outside of the function. If you alter this value within the function scope, it will affect only the value inside of the function. We can either return the value of the variable with the function return option or define it outside of its scope. Okay, so we told before that a function can return a value. I want to show you something. Here I've sent this x and y to the function. What would happen if I defined a z and I will give it the value 99? This z cannot be accessed here. Okay? You see here? Z is unknown. Let's say I would define a z here and I will say that this z equals 77. What do you think would happen? First, this z is a global variable. We'll talk about it in a second. From the point of view of this z, by the way. Of course, that this z is defined only in the scope of this function. And if we'll do x plus z, let's see what happens. See, here it was printed 107 because x value was 8 and the z value was 99, and then I try to add z to x. Here I've printed the other z. Even though they have the same name, this one is only defined in the scope of this function. Okay? And about return value, another thing that we can do, we can return the value of z by just stating return. You see it's an orange word, so it means that this word is reserved by Python. So I'm returning the value of z from this function. Now if I want to have z here, let's say I can call it z from function. That's the name of my variable, and let's say it would be equal this. So what happened in line number 17? Line number 17, it's the same as it was before. It just would call the function with those two numbers. As you can see here, by the way, there is a warning. We talked about it before. It said missing white space. Of course, this warning won't affect my code, but in order to make it more conventional, we need to add this space here. Okay, so we call this function with the same numbers. Nothing has changed here. The only thing that was changed is now that this function returns a value. This value is the value of z. So it means that after those print in line number 11 and 12 would occur, we would return this value of 99. Then we can print the value that we got from this function. Okay, so what happened here? You see there is a print. Here it was printed 107 because we sent the function. The x was 8 and z was 99, and then we return the z value. A global variable is something that we require sometimes, and we want to change the value within a function or outside of the function. Let's say in our scope that the file that we've just created, if we'll declare a variable outside of a function, we could access it from within the function and we might alter its value. Let's have a look at the global variable. Let's say here I would define a variable that I would call my global variable. It would be 46. Now let's say that I want to access this my global variable. Because we need to tell Python that this variable is a global variable, it's not something that was defined within the scope of this function. We need to tell it global, my global variable, and then we can deal with it. We could say that my global variable equals my global variable minus y. And if we'll try to print out, let's do two prints. One will print my global variable before we call this function, and then let's delete this print and we'll print it after we call this function. I remind you, whenever we'll call this function, the value of this global variable that was defined here should change. Let's run it. Okay, you see here, before we called the function, it was printed the original value, which was 46. Then we sent our function the values 8 and 5. Then the value of my global variable was altered inside of the scope of this function, because we told this variable that now his value is the original value minus y. Of course, every time we'll call the function. Now if I'll call the function again, let's say I will just call it again. Now with 1 and 1, okay? What do you think would happen? After the function would, I would call it one time. Now the new value should be 41. Then if I'll try to print it again, I expect now that this print should be equal to 40. As you can see here, that's exactly what happened. Conventions. You probably noticed that whenever I created a file or function, I follow the lowercase convention with an underline between each word. There are other conventions in Python. For example, a convention for constants and for classes. About classes we'll discuss later on, but usually you should follow this convention. All of the definitions are a lowercase variables or functions, and whenever the function name or the file name that I have contains more than one word, I would separate those words with an underline. By the way, you see I have a warning here. It said expected 2 blank lines. I found only one. I told you about some warning before. I could ignore this warning, or I could just align with the conventions of Python. Okay, now there is a 0, so I need 2 blank lines here. That's it. Now I have no warning. Here what happened? It's the same warning. Yeah. Maintaining your code is very important. If a code is not readable and not comprehensive, it's easy to get lost. It's easy to get some cluttered code. A lot of people like to call it a spaghetti code. So a good code should include some comments whenever something is unclear, whenever we do something that another person might think otherwise. And we have some other stuff that we can add to our code and to make it more appealing. We'll study it in the next section. Comments are useful tools to add to our code in order to make it more comprehensible. Sometimes we would like to comment out a certain portion of our code in order to skip over it and deal with it later. There are 2 types of comments in Python. Let's have a look. The first type of comment is used by a hashtag, and then I can just write here, this comment is regarding my first function. As you can see, line 3 is grayed out. It doesn't matter what I will write here, everything would be grayed out. So whenever I execute this code, the interpreter won't pay attention to this line. It will just skip over it. Why is it good? Because sometimes when we have a large file, or maybe some code, we did some calculations that are not so, let's say, understandable by another person, and another person might look at our code, let's say, for example, this function, okay, this my parameterized function. Of course, always you should aim for the best possible name for a function. It shouldn't be too long or too short. It just should describe the function that you are writing in the best way that is possible. In this function, I don't know why we did the x plus z. It was just for an example, but let's say this calculation has some significance for us. So we could write the comment somewhere here. I've made the following calculation to demonstrate how a local variable value, by the way, we can continue in the next line, we'll just add another hashtag, how a local variable value doesn't change outside the function scope. That's an example. Also, a very useful thing to do is to sometimes we want to gray out. Let's say in this type of function, by the way, you can also write a comment. I'm sorry, I'll go back to what I said in a second, but you can also write here, this is the value of z. And because of that, you see here, this code would be executed, but at the same line I have the hashtag. From this hashtag until the end of the line, whatever I will write here is just a comment. So the interpreter would ignore it. Why I have a warning here? Let's put it at least 2 spaces before inline comment. Yes, this type of a comment called inline. Also, another useful usage of a comment is that we can just gray out something. Let's say that I don't want to print this calculation because I miscalculated, or maybe I don't want this prints now to appear. You see, I have too many prints. I just want to return the z value, just it for now. And also I would like to change the value of my global variable. So I can, let's say I want to comment out all the prints, also outside of the function. Sorry. The space from the hashtag is not mandatory, but I get a warning if I won't do it. So let's just run it now. You see, we have now only 3 prints to the console because all the other prints are grayed out. The only 3 that I have is the print that we had before. The first one is from here. I'm inside the second function. The second one is from here. I'm inside the function. And the third one is here in the end in line number 29 after I return from this function. So why do I need to gray out my code execution? Let's say I'm checking something. I want to develop something. In my profession, I'm developing automated tests for browsers. Sometimes I want to open the browser to see some actions that I've performed with my code, and then in the end I want to close the browser. But while I'm testing, maybe I would like to leave the browser open to see the end result before the browser is closing. So let's say I want to have this line, but for now, during the development process, I want to just gray it out because I don't want that this line would be executed while I'm developing. Maybe there is some line of code that I don't know what it does, but I don't want to delete it, so I will just comment it out and maybe I can deal with it later. By the way, as you see here, because I grayed out the only line that deals with the x value, now the x also is grayed because it's never used. If I'll just delete the comment here, the x is white, is like illuminated again and not grayed out. Okay, so this is the first type of a comment that we have. Another type, as you saw here, I had two lines. If you want to have like a block of comments, you could use 3 quotation marks. And this is the closing, the opening of this quotation mark, and this is the closing. So here I can write a code and it would register as a code, but if I write something here in the range of those 3 quotation marks, you see, nothing happens here. Def my commented function. You see, nothing really happens here. And also, PyCharm doesn't autocomplete my function. Let's just do something. I will show you. Print I'm a commented function. Okay. It wants another. So here I can just gray out a whole block. I can do as many lines that I want. I can also move it down. Let's say I want to gray out also this function. I want to comment it. So we can see that now the comment starts here in line number 13 and it ends in number 27. But now I've created a new problem. Why? Because I commented my parameterized function and now my code doesn't know what this function is. So it was a bad idea to do it here. So again, let's go back. I took those 3 quotation marks and I pasted here under this function, and now only this section is commented. If I want to cancel it, of course I just need to delete this, and I have a new function that I can use. Okay. Also, because instead of just using this hashtag here, maybe it was a better idea to use the second type of a comment. And then, see here. So, if I want to write some long text that that won't affect my code, I could use it here. You should be careful with comments because it's easy to give a comment on anything, especially when you are a beginner. So you have a really long loop or a function and you want to state this is the end of the function, this is the end of the loop. You could say in a place, let's go back to our previous demo. Let's say here, I could say that this is the end of the for loop. But those comments might be considered as redundant because whenever an experienced programmer see a lot of comment, so it may make also a lot of clutter and make our code look disorganized. So my advice to you, whenever you feel that your code needs some more clarification, if you can be inside the shoes of another person, and you might think that if another person would look at your code and this person might ask himself or herself what this code means. So maybe there is a room for clarification with a comment. So those are the main usages of comments in Python. Casting is used in order to convert data, like a data type, to another type. Casting in Python is done easily by specifying the type that we want to cast and surround the original value with parentheses. We'll look at an example in a second, so don't try to memorize it. And also, the end result should match the type that you are trying to. Otherwise, we will get an error. So let's demonstrate it also with an error. So let's say that I have a value, my x value, and let's say that this value is 54. What is the difference between defining this like with those quotation marks and the difference my other x value? What do you think is the difference between this one and this one? In both cases, we have 54, which is a number that we can use. We can do stuff with this number. We can maybe divide it. Maybe we can add it to another number because it's an integer value. In order to extract the integer value from here, because now it's a string, do you know that I won't get any error if I will write down 54 oranges on my tree. By the way, I do have some oranges here on the tree, but they are still green and they are not ripe. So we need to wait a while before we can taste them. Okay, so this is a string. It doesn't matter that it has an like integer value, like a number in it. It's just a string because I have those. If I'll drop those, of course, I will get an error because Python doesn't know what it means. Okay, this is a numeric value, and this is what is it? So it's either a string or a number. The same goes here. If I will add some, let's say, oranges, now I change the type and Python doesn't know what is this type. So let's go back to the original example. Let's say that I want now to perform this one. Let's say call my function subtract, and I will provide this function a first number and a second number. And I will return the value of first number minus the second number. And now I want to send this function those two numbers. I could try. Let's say I'm trying now to send those numbers to this function. So I will call subtract, and I will send my x value and my other x value. Of course, Python is very forgiving. In Java, it wasn't working because it would say that this type is a string, this is an integer, and it won't even allow me to write this line. I would get an error here and not just a warning. This warning also is not even on the data type. So let's try and run it to see the error that we're going to get. I didn't get any error, which is strange. Let's try to print it instead of returning it, okay? Ah, yeah, because I called it twice with my other x value and not my x value. Let's run it. What did I get? Unsupported operand for str and int. I tried to perform an action of some number to another number, but I provided a string value. So how can I cast it? I can do it in, let's say, if first num is str, I want to cast it, I want to change it casted. I hope that this term is correct. How do I cast it? I just say int with parentheses, and inside I provide the value that I want to cast. Now I can say that let's print this one now. But now I'll use this one. Sorry about that. Okay. Else I will go with the regular. I'm asking, is the type of the first number equals string? Now let's run it. Yes, I got it. I got the 0, which is the result of those two numbers, like subtracting this number to this number. By the way, I can add the opposite side, and then my function might be a bulletproof, by the way. How can I do that? I'm asking if second num is equal string. Let's write down this one. Second num casted and then I can print this. But now it will be first num minus second num casted. You've probably seen another problem with my code, and the problem is that this value is local. What it means? Let's say both of them are strings. So in the first time I will go inside here, I will ask, is the first number is a string? Yes, I will cast it, then I will print it. But what would happen if the second number is also a string? What do you suggest? I could manipulate the code. Maybe I can change the original value. Let's change the original value and not the... What happened here? So I got the value. I asking, is it a string? Yes, and if it's so, I'm assigning the new value, the new integer value, to the first number. And then I'm asking the same question about the second number. And again, I'm doing that here. So this print is not useful anymore. And then I can also delete the else. So in the end, by the way, this print now, because it's indented under this if, it would occur only if this if would be true. So I will backspace it in order to be on the same level of those if. So now again, my function would ask, if the first number is a string. If so, cast it to an integer. If the second number is a string, if so, cast it to an integer. And in the end, I'll have this result. Let's try to run it. And as you can see, it's working fine. It would work fine, by the way, also if I will change the value of the second number to a string as well. Let's see what happens here. Now it equals 49 because this value is 5, this value is 54, and my function does the 54 minus 5, and that's the result of that. By the way, what do you think would happen if I will change this number to not to be a string, let's say to be an integer, to be a real string? Let's say I will call it Rain, which is Rain the dog, our dog. I probably would get an error because I'm trying to cast something that is not string. You see, we got a value error, invalid literal for integer with base 10. It doesn't know what to do with that. By the way, whenever you get an error, usually you could also get the line number. So it's line number 44, which deals with the second number, and it's trying to cast it to an integer. And it's not an integer because it's Rain. I hope that you understand this explanation. In a second, we also study how to cast a string. Now we could study some more about advanced prints. When we use casting, we can deliver much more dynamic and customized messages to the console. We can concatenate strings and integers and even strings to strings. There are also methods of formatting strings, but we won't deal with them in this course. So let's just do some more advanced prints. Advanced, let's say, compared to what we know already. So let's say that I want to print something here. No, you see, I print here the result of this calculation. Let's say I want to tell the user, I could do two things. I could print this is the result of the first number minus the second. Let's see what happens. Okay. But you see here I have two lines because I printed it and then I printed another line. Let's say I want to combine them together. So I could take this line, this string, and paste it here, and then I can just use plus and this. It's not the end. We're gonna get an error, and I will tell you why this error, but the basic structure is like this. So I'm having this string, and then I'm concatenating the result. Maybe I can put it inside a parenthesis that I would know it's some kind of an equation. Okay, now it looks more readable, but we're going to get an error. Let's see this error and we'll solve it together. Okay, now Python is being a bit confused because it's getting a type error, because we already started with a string, and then Python is telling me, what the hell are you doing here? Because I have a string, and then you're trying to concatenate an integer. Just tell me what to do. So it can be resolved in a very simple manner. We would just add str before these parentheses. Now, inside the parentheses, this is like a normal math equation. The first number minus second number would give an integer result. After this one will be performed, then it will be cast to a string, and then it will be concatenated to here. By the way, you saw here that I've done a space, because if I won't do that, So the result would print just after those colons. So I've added also a space. Let's run it again. This is the result of the first number minus the second, and the result is 9. See here, now it's much more dynamic. By the way, if I would change it to 141, of course I will get a different result. Now it's minus 91. And if I'll change this one as well, let's change it to an integer, it will be this number. You see, I get a different result. So that way we can print in a much more dynamic way. By the way, in Python you can easily, because you see this line goes all the way here, and also I have some white space. Okay, you see this line is too long for us to view. You can just press enter somewhere, and those two lines are connected, and now it's just a bit more readable. Also, by the way, because it's strings and integers, I can also concatenate a new string to that. Let's say, whoa, dot, whoa, that's cool. Let's run it. Now you saw here, this is a string. This would be always a string, and then I have a result which is two integers that are casted to a string, and then another string is being concatenated to the whole sentence. So I have like double-sided casting. Sometimes the number is a string and then I cast it to an integer, but in the end I'm casting everything to a string because I want to print it out. Hints. Hints are very useful and help us to understand the data type that we are dealing with. By the way, hints in Python are not mandatory. You could use hints. I do recommend you to do that, and you can also hint the return type of a function. Let's go back to our code and we'll add a lot of hints there. So let's start from here. So Python is very forgiving, is very easy on us, and it doesn't require that we would tell that this variable is an integer. But we might want to tell it to someone that is reading this code. So in order to hint it, we do use parentheses, and then we can say this one is int. Now we just hinted the data type. By the way, what do you think would happen if I will transform this integer to a string? Nothing. I told you, hints are not mandatory. Python would just, PyCharm would say, I expected the int because you hinted that it's an int, but you wrote down a string. So it's just a warning. Okay, so you could do it on any type. Let's say here, let's say that this type is an str. So I hinted here that this one is going to be string. Also, when I return a value, I could hint the return value. Let's hint the z, it's an integer. And I could use this arrow to tell this function returns an int. So whoever would return the function would know that this function returns an int. Let's see that in action. Whenever I have a parameter, let's call it my new param, and it would call my parameterized function. You see, if I just mouse over it and I in Mac is Command and Windows is Control. I'm just holding this button. I can see here, after you see the int in the integer in like painted in blue, I see the return value over there. Of course, that if my new param would be hinted to be a string, I would get this warning. It told me, you expected to get a string, but I'm returning an integer. So I do recommend use hints. They are very useful. I know that Python is like a really more free spirit language that doesn't require those heavy structures like Java and other programming languages, but it does help for other people to understand your code better. Using a debugger is one of the most essential tools in every programmer arsenal. Whenever we want to execute a code and then pause it while it's running, we could use breakpoints. I will show you in a second how to add breakpoints to your code. Adding breakpoints are easily one of the best strengths of PyCharm. Of course, you could add breakpoints in other softwares as well. And we'll study now how to use the basic functions of a debugger. More advanced debugging won't be dealt in this course. If you would like to see more, please write us in the comment section down below, and if you think it's useful for you, maybe we can do like a whole video just about debugging. So how do I even add a breakpoint? Let's go back here. This is my function, my first function. Let's say that I want to stop before I'm calling the other function. So you see the space that I have between the number of the line and my code. I just press here. Now I have this red breakpoint, and also the whole line is painted with some red color. What would happen now? See here in line number 30, I'm calling this function. By the way, I can also add breakpoint here. I can add breakpoints in other places, but for now we'll have only one. The only one breakpoint that we have is in line number 5. But line number 5 won't be executed until we'll reach line number 30, which is the one that is calling this function. So let's right click on our code, and instead of running it, we'll debug it. Okay, you see here, now it's painted blue, and we have the debug, let's say debug console is now open. Here there is a really nice window that we'll see in a second, and now it's stopping. So I have two options. The first one, I can just step over it. Step over it, it will mean that this code would be executed without any breakpoint, and then I will just go here. So now my second function was performed. By the way, if I look at the console, you see, now I have this print. I'm inside the second function. Let's go back to the debugger. Now, if I'll step over this line, the second print would occur. You see, I have a new message in the console, and now the second print occurred. Now it went back to the line that called all of this, and you see the debugger also is skipping over the commented outlines. Now let's say that now my parameterized function, I want to step inside because now I'm in line number 32. I can just press step into, and now I'm here inside this function. You need to pay attention to some interesting stuff here. Let's go back to the debugger, by the way. Here you have those the values of the x and the y, and also you have it here in the debugger. Now, after I'll step over line number 20, I will have the z added to my variables as well. This is like, let's say, the snapshot of my current memory, because I've stored those two values in the memory. Let's step over it. Now you see I have three values. The latest one is z, and the value in it is 99. It also writes it here, only during execution time. Now I'm here in line number 23, and if I will step over it, it would print the result of x plus z. You see, here is 107. Then I've called my global variable. By the way, I can just mouse over it and PyCharm would tell me that the value here is 46. If I'll step over it, you see here I'm changing the value. The value of my global variable is 46. The value of y is 5. And I'm performing 46 minus 5. So now the result should be 41, because it was 46 minus 5. Now I'm returning the z. And after I'll step over line 32, another variable would be added here. See? Now the z from the function is 99. So it gives us a snapshot of what happened in our code. Now the only thing I need to do if I want to end it, by the way, I can, during execution time, I can add another breakpoint, and I can also, if you want to step into a function, you can just press it again. And if I want to continue executing until the next breakpoint or until the end of the function of the execution, just press the resume program. Now the program ended and all of the prints are performed. You see that now the process was finished. So use a debugger, it's very nice. If you want to clean the breakpoint, you can just look for it and you could press here. By the way, in PyCharm you can also look at all of your breakpoints from a certain place. Here you see under run you can see view breakpoints, and it would show all the breakpoints that you have in the code. We probably left one in the previous file here. This is the last section of our course. Here we'll be graduating from beginners to a bit more advanced Python programmers. We'll study about nested loops and conditions, lists and tuples. We'll also have a look at Python and object-oriented programming. What are lists? Lists are very useful data structures. It can hold any number of parameters. One of the best things about lists in Python is that you don't need to initialize the data structure, and you also don't have to tell which data type are you using. A list can be nested, for instance, to a two-dimensional list which represent a matrix. Think about an Excel spreadsheet that has rows and columns. Of course, a list can be nested to more than two-dimensional, but we won't deal with that in our course. Tuples are data types that are used to store various types of elements. Whenever you initialize a tuple, all the elements will remain in the exact order that you declare. Once initialized, a tuple cannot be modified. It is better to use a tuple whenever we desire to create a list that cannot be altered, as opposed to the dynamic nature of lists, that we can add elements, we can change the order, we can pop out some elements, and etc. Tuples are much more strict. Think about whenever you want to download a JSON file and you want to store it in a data structure that you can read with your Python code. Usually, it's not a good practice to alter a data that was generated in another place. So you can store it in a tuple, you can read it, and then use it in your code. Let's look at some examples to make it more clear to us. I'll remind you, you click somewhere in our project, even on one of the files, you right click on it, and then you choose New Python File. We'll call this file Advanced Demo. First, we'll declare our list. We'll call it my list, and then we'll just say it's equals to brackets. Now we have an empty list that doesn't have any members. As you can see, PyCharm already recognized my list as a list because of the brackets. Now, if I'll use the dot right after it, I have a lot of options here. I have append, index, sort, and etc. We won't deal with all of them, but we'll go over some of them. Now we'll choose append, and let's say I will append the number 1 to it. Let's print this list, which is called my list. Okay, now we can look at the console output. We can see that our list was printed and it has only one member, which is the number 1. Now let's append another number to it. We'll choose 4, and then we can append also 9. Now let's print it. This list has 3 members, 1, 4, and 9. There is another option, by the way. Instead of using append, we can add numbers upon creation to the list. We'll just add some numbers inside the brackets in our first line of code. If we rerun it now, we can see that the list consists from the numbers that we started the list with, the 2, 3, 5, and 6, and then all the other numbers 1, 4, and 9 that we appended to it. The order of the list now is the order that we inserted the numbers to it. But if we want, we can now print the list after we sort it. Of course, we need to cast it to a string, and then we can put inside the brackets my list.sort. There are some optional values. We can sort the list backwards, or as in a regular, we won't use any other option, we'll just use the default one. Now we expect the list to be 1, 2, 3, 4, 5, 6, and 9. My order list is none. Oh, we made a mistake. I don't need to print that my list.sort. I just need to use this command first, and then I need to reprint my list. So let's move it back. Now it's in line number 6. Now let's rerun it. Okay, as you can see now, our list is sorted. The original one was printed. The order was 2, 3, 5, 6, 1, 4, and 9. And then the sorted list was sorted correctly. Of course, a list can consist of other elements such as strings. Let's look at an example. Let's say that I want to have a list of all of my Apple stuff. I have my MacBook, I have my iPhone, I have my iPad, and also I have my AirPods. Because I use the parentheses and not the brackets, now it's a tuple and not a list, by the way. So let's change it to a list. We'll just change the parentheses to brackets. And just now, let's print it. As you can see in the console output, we have MacBook, iPhone, iPad, and AirPods, which consists my str list, my strings. If we look at index, you know that index starts from 0. MacBook is in index number 0, and then in index number 1 we have the iPhone, index number 2 we have the iPad, and in index number 3, which is the last and fourth one, we have AirPods. Now you could see that whenever I want to access one of those elements inside my string list, I can just use a number. Number 2, I expected to print iPad because it starts with 0, the MacBook is in 0, then the iPhone, and then the iPad. By the way, I used casting to str just to make sure, but Python should know that this list consists of strings, so the str here is redundant, we can just ditch it. Now let's try to sort our list like we did before. Now if we rerun it, in index number 2 we have the iPhone, because now the order is a bit different. The AirPods are the first one, then we have the iPad, then the iPhone, and then the MacBook. Of course, the sorting here is made in a lexicographical order, just like in the dictionary. Let's now reprint the list after it's being ordered. Here I need to cast it because it's a list. Just like we expected, the list is ordered in a dictionary lexicographical order. So as you can see, lists are very useful to store data. In our first demo, we studied how to use a for loop that is running from an index in a certain range. In the other case that we saw, it was in the range of 11. Now we will study about a variation of a for loop, which is very useful when iterating over a certain data type, such as list and tuple. We'll say we want to go over 4 items in my Apple stuff. Item can be any variable that you want, it's just the name of the variable. I found it very useful to call it item. Now every time this loop would iterate over my Apple stuff, I want to print the value that is now stored under item. So this for each loop will store the value inside item every time it iterates over my Apple stuff. We don't need to use indexes. In this case, this loop would run 4 times because we have 4 items in my Apple stuff. Let's run it. Now you could see that the first time it was stored under item AirPods, then iPad, then iPhone, and in the end it was stored MacBook. Tuples, by the way, are very similar. Let's define a list and we'll call it my tuple list. We'll define the first element to be the first member of this tuple to be first element, and then second element, and a third element as well. Now let's print it. As you see, it's a different kind of list, but now that's the only order that we have. We can resort it, we can add new members to it. We could use index and count. Those are mainly practically the basic methods of tuples. By using count, for example, it would count how many occurrences we have for a certain element. If we'll add another element, which is called exactly first element, just like the first one, now we'll run it and we'll find out how many occurrences of first element we have. If we'll add in the end of the tuple another first element, just an element which is called exactly the same as the previous one, and we'll re-execute it, now we have the number 2. How do we iterate over tuple? We'll use the same one, we'll use the same name of variable for item in my tuple example. Again, it can be any kind of a name for this type of element. And let's print a nice message. I am a tuple item. Then we'll just concatenate the item to it. Let's rerun it. As you can see here in the console output, we have the I'm a tuple item first element, and then the second element, the third, and the first again, because we added the first another time in the end of the tuple. Let's declare a variable which we call it a counter, just to demonstrate how many times we go over this loop. Let's say every time we step into the loop, we'll add 1 to the counter. We'll advance it by 1. We also will add to the print my counter. We need to cast it. Now we have and my counter is the counter. At the first time it will be 1 and etc. Now you see, and my counter is 1, and my counter is 2, 3, and 4. Nested conditions. Conditions can be nested, which can provide an advanced functionality to the original condition. Make sure to pay attention to the indentation in your code. Of course that if we'll declare variables inside a nested condition, there cannot be accessed from a higher level because they are local. Let's have an example. We'll head over to our for each loop, which deals with my tuple example. Let's say that we only want to print the first element at the first time that we encounter it. We'll just add a condition here. So if an item equals a first element, that's the string, the string value of this item. Now we'll have a nested condition under it. How do we know the length of this tuple? We could just count it manually. We could say it's 1, 2, 3, 4, that's the length. Or we could use a predefined function in Python which is called len. Now we would ask if the counter is smaller than the length of my tuple example -1. By the way, why -1? Because the general length is 4, but since we're starting from index 0, the last item will be 3. Now this will be print only once. You see here, I'm asking if the item is the first element and also if the counter is not in the end of the tuple. That's the only time I will print it. But now we don't print the other elements. So let's alter the condition, else we'll print it anyway. So now the condition relates only if the item is being called first element. If we'll encounter another time another item which is called first element, we'll check if it's not the last time that we see it, like in the end of the loop. Otherwise, we'll print the item. Of course, we could store the value that we've encountered it already, and to see if not it's just the last element, we could alter the condition to make it much more, let's say, complicated. But just for now, in order to understand, we could see that the output here is that we have the first element printed, the second element printed, and then the third one. But the fourth one wasn't printed because of our nested condition. Nested loops are very similar to nested conditions. It is useful to use a nested loop to iterate a matrix. Usually, a good rule of thumb is to keep a nested loop in 2 dimensions. Bigger nested loop usually indicates a bad coding. Of course, there are some situations such as you maybe designing a 3-dimensional object and you want to go all over 3 dimensions, but in most cases, whenever you see a nested loop that is bigger than 2 dimensions, usually it's indicating bad coding. In this section, we'll study about a 2-dimensional nested loop. Let's watch an example of a nested loop. Okay, so let's define a 2-dimensional matrix. The first brackets of the matrix, those are the brackets of the rows. Inside of them, we'll enter more brackets for the calls. The first bracket will be the first row. We'll add 1, 2, 3 in that. Each element should be divided by a comma. Now the reason I'm opening a new line for that is just for let's say visibility of the code, readability. We could write it in one row, but I think we can read it better when it's divided to 2 rows. So if we'll overview our matrix, we could see that the first row will consist of 1, 2, and 3. Then outside the brackets, we use a comma, and then the second row would consist of 4, 5, and 6. In order to get any number in this matrix, for instance, let's say I want to get number 2. Number 2 is located on the first row and in the second column. The second column, which means if we start from 0, it will be row number 0 and column number 1. This will give me number 2. The first loop will iterate the rows. We can call the index for that I. We could call the index in any name, but usually the convention for the rows, usually it's I. So we'll say for I in range, the range is the length of my matrix. Inside we have a nested loop. We'll say for J in range, J usually is used for the columns. Now again, where the range is the length of the matrix, but now the length is in the I position. This inner loop is a bit more complex, but I bet you understand that. Every time we iterate in each row, the nested row, will iterate this row for each of the columns. Now inside the nested loop, we can print the element in the position of the I, which is the row, and then the J, which is the call. Let's run this loop and then we'll put a breakpoint and debug it. Now we can see that we have all the numbers printed, line after line, 1, 2, 3, 4, 5, and 6. Now I'll put a breakpoint in line number 35 and we'll go over it. Now let's debug it. Here you can see that the I is equal to 0 on the first iteration, and then j wasn't even defined yet, but we can iterate it. Now j equals to 0. The number that we are going to print now is the number which is located in line near 0 and column 0 as well. It means that it will print 1. Let's step over it, and yes, you can see that 1 was printed. J is being advanced in 1. Now j equals to 1. Now we're asking the matrix to provide us the number which is located in line 0 and cell or call 1. Now number 2 is located there. You can see in the console output that 2 was printed. Again, now j equals to 2. We expect now that 3 would be printed. After we'll finish this line, this row, we expect the I to advance. Now we can see that the loop went up 1 level. Now the loop that is like the parent of the nested loop is being advanced by 1. Now the I is equal to 1. Again, j equals to 0 because we redefined the j. The inner loop lives in the range of the upper loop. And then we print the number 4, which was in line number 1 in index 0. And then it will go to the index 1, which will print the number 5. And in the end, it will go to index 2, which will print number 6. Now we have all the elements printed. We can continue to execute the code, and now the program just finished executing. I hope that you understood the previous section. If not, please go over it again, and if you would like to know more, you can always comment in the comment section down below and provide us with some questions. Maybe we can answer them. Please do that. Python usually is being used as a scripting program language, but Python is also fully compatible with object-oriented programming. It means that the basic structure of our project should be assembly of objects. Objects are special blueprints that need to be initialized first. I know that in this course we haven't provided a sufficient background for object-oriented programming, so in this section we're just trying to demonstrate and give you an example of how Python looks as an object-oriented language. One of the best advantages of object-oriented programming is that we can initialize an unlimited number of objects of a certain type. Let's try it out. Let's right-click and open a new file. We'll call it OOP, which means Object-Oriented Programming Demo. Now we will define a class. A class is a blueprint of an object. It represents the object's characteristics, the method, and everything that is included within this object. The convention in Python for naming a class is to use camel letters with the first letter as a capital letter. Camel letters mean that each word would be marked with an uppercase letter. In this case, my class, the M is an uppercase, then followed by lowercase letters, and then class is the second word, so I'm using class with a C. As you can see, there is a warning in the parentheses of the class because this class doesn't inherit from other classes. We could remove it, but let's just keep it for now. Let's define a method now. By the way, now, because we're defining a class function, we call it a method, because now this class should be first initialized. Let's call it my first method. As you can see, as soon as I completed the parentheses, I have now this built-in parameter which is called self. Self will represent the instance of this class. Always when you define a method in class in Python, self should be the first parameter. Then the self can be followed by any given parameters, just like in function, separated by a comma. Let's call the first parameter first number. Let's say that this method will give us the power result of a certain number. For example, we provide number 2 to this method. This number 2 would multiply itself and will give back the value of 4. Let's define my new number, which will be the result of first number multiplied by itself. Now we can print it. We can print the string the result is, and we can concatenate the result. Of course, we need to cast it because it's an integer. We can call this class, we can initialize this object from anywhere. I prefer to go back to the previous file and to call it from there. But you can do it from the file itself. Now we will define our first object. We'll call it my first object. Now it's equal my class with the convention of the camel letters. It will be followed by parentheses. Now we have an error because our code doesn't recognize it. If we'll press the bulb on the left hand side, we can import from object-oriented demo, we can import my class. Now we don't have the error after we perform the import. Now the object was initialized. Of course, on runtime it will be initialized. We can now call the object followed by a comma, and then we have all the options that we can, all the actions that we can perform. Here we can see our method. Now we call this method with the number 3. If I'll run it for now, you could see that it was printed in the console output. The result is 9. What is the main difference between this method to a regular function? Why do we even need to initialize an object? Let's answer this question with a simple demonstration. In order to demonstrate the significance of using a class, we'll start by defining a special method which is called a constructor. In this course, we won't go deep of what a constructor is, but first let's declare a variable. We'll call it a username, which is from the type str. Now I'll use a result function called init. This method will initialize my function. Let's say that this method, whenever this object is being initialized, knows how to get a parameter which will call it a name. It will be a string parameter. By the way, this method is started and being followed with 2 underlines. Those underlines means that this method is private, is being accessed only privately from this specific object. The private, public, and protected are not part of this course, but maybe we can go over it in another session. Now we define a name, which is the parameter that this function receives. Then in line number 4, where we need to assign this variable to our global parameter, which is the name of this parameter is username. Of course, because this is part of this specific instance of this object, we need to access this specific parameter by using self followed by a dot. Now, whenever we initialize the myClass object, the only thing that we need to do is to provide some kind of a string to it. In this case, I will provide my name, Yair. And now let's say we want to initialize a second object. We'll call it my second object. So it will be the same syntax. We'll assign my class with camel letters. Now, when we initialize, the name is Rain, the magnificent dog. Now, the only thing that we need to do, let's say I want to print my first object dot username, and then I want to print my second object dot username. The first time, this global parameters is holding the name Yair, and in the second one, it's holding the name Rain. This is part of the beauty of using objects. You see, I can use the same blueprint, but then I can assign different values to each one of them, and they are unrelated. If I want to run in a parallel mode, or if I want to use some multitasking, so of course I would use objects. Then, because those values are not mutual, they're just from the same type, from the same class, so they don't interfere with each other. Of course, this part of object-oriented is just like the tip of the iceberg in this particular field. We'll just finish this section by saying that you saw here that an object can be initialized with parameters, but there is also that an object in Python can inherit from multiple ancestors. Inheritance in object-oriented language is one of the key features. It means that a certain object can inherit all the characteristics, all the methods from an ancestor. So we can reuse this code instead of just rewriting a code every time we need to use it. We can use inheritance in order to get and acquire all of these specific characteristics of a specific ancestor. In Python, there can be a multiple inheritance, so one object might inherit from several ancestors. This is something that is more unique to Python, and you won't find it in Java, for instance. Now let's look at a really quick example. Let's define a new class. We can do it in the same file. We can create a new file. We'll call it my second class. Now inside this parenthesis, we could say that this class inherits from my class. So now we could say that my class is the parent of this my second class, that class that we just created. We'll use pass to tell that this class doesn't do anything, it doesn't contain anything, but by using the inheritance, it means that my second class now acquired all of the methods, all of the characteristics, all the protected and public variables that are in the ancestor. Now let's try to initialize an object. Now will be based on my second class. Here, of course, we need to provide a string for that, because of course we need to import it first, and then we need to provide a string because it inherits the same init method that is located in the previous example. Now we can access from this object the username, and you can see that it was printed to the console Yair2. Let's overview that again. We defined a second class. We didn't want all of this functionality to be redefined, so we just used inheritance and then we acquired all of that. Of course, that under the scope of my second class, we can include new method, but those methods won't be recognized by the previous class because this class is the ancestor, but the child of this class, my second class, can add any kind of method and they will be unique to this class and also to the descendants of this specific class. As I told before, we could declare more ancestors. They all need to be followed by a comma. I would like to take this opportunity to thank you all for participating in our Python course. It was a pleasure to teach you all. If you have any kind of comment or a suggestion, please do it in the comment section down below. Please click the subscribe button and hit the bell icon in order to get the latest video whenever we release a new one. Thank you all for watching. Have a great time.